So in this lecture, we are going to talk about the Diels-Alder reaction. Now, the Diels-Alder reaction is a very useful synthetic tool for preparing cyclohexane ring. This reaction was developed by German chemists Otto Diels and Kurt Adler in 1928. Now, what is the Diels-Alder reaction generally all about? Now, it's a cycloaddition. It's a 2 plus 2 cycloaddition reaction. We are going to look at what this means as time progresses. Now, first of all, the reaction is between what and what? Now, the Diels-Alder reaction is between a diene, which is this, and a dienophile. It's between a diene and a dienophile. Now, as the name implies, dienophile, it means diene lover. Are you getting it now? Or diene loving? Because phi means what? Love. So dienophile means a diene loving molecule. So how does this reaction occur? It occurs in just one step. And we said that whenever a reaction occurs in one step, what do we say? What do we call it? We say it's a concerted mechanism. So the reactions or the other reaction is a reaction that occurs in just one step and is concerted, and it involves a reaction between a diene and a dienophile to form cyclohexane ring. Now, how does this reaction actually occur? It's very easy. For instance, you see these two react. This is a diene and this is a dienophile. What is a diene? A diene is a molecule or a compound that has a conjugated double bond. Are you getting it? When we say something is conjugated, it means after the double bond, you have single bond, then the next is what? Double. This compound is conjugated. Now, however, if I give you a compound like this, and then you have double bond here, double bond, this compound is not conjugated because after this double bond, you have single, single, double. So the diene is a conjugated double bond, and the dienophile is a diene-loving molecule. Now we are going to look at this duo, the diene and the dienophile, which is actually required, as in what kind is required, what kind of dienophile is fit for this reaction, because not all kinds are fit. There are some of them that react very well, and what makes these ones react very well, we are going to look at them, okay? So how does this reaction actually take place? It's a very simple reaction. This double bond here is a perfect nucleophile because we said double bonds, they are nucleophile, they are rich in electrons. So this double bond here reacts with this, react here, and as this double bond is coming here, what happens? This one will pack up here. As this one is packing up here, this one can no longer stay here. This one will what? We pack up to this place. Are you getting it? This one will do what? We come here to form the ring. So what is the product of this reaction? It's a very simple reaction. This one comes here, so the product will be something like this. You have this, and then this, and then you know this bond has packed here, so we have something like this, okay? And then you have your CH2, you have your CH2. Are we getting it? Then this bond here, this one that came here, it will form a linkage like this here. Are you getting the fact now? So this one that also came up here, we've also formed a linkage here. Then we come back to this bond here, which is this. So you see that it has now formed a cyclic ring, okay? And then we now have, but this bond now is not doubly bonded, the single bond. Then we now have something like this, like this. Then we have this oxygen, and then double bond, oxygen, double bond, oxygen. So this is the product of this reaction. Now, if I want to write this product without actually writing any CH2, I can say the product is something straightforward, which is this, double bond oxygen, double bond oxygen. Okay, so that is the product of that reaction. Are we getting it now? So now the reagent used in this case is benzene. So that is the cycloaddition reaction, the diaeder cycloaddition reaction, and everything that has to do with it. If you understand this principle, then everything will become very easy for you. Now let's look at the next. For instance, if you are given this compound, you ask what will be the product of this reaction using the diaeder reaction. If you heat the together. Now the first question you need to ask yourself is, which of them is the diene? This is a diene, and this is a dienophile. Now, this thing can react in two ways. I'll first of all react it in the first way, then you try react it the other way and see. Now, if this CH2 comes here, what do we say will happen? This double bond is coming here. What do you say will happen? We say this one will pack up here. This one is packing up here. This one will come here. Right? It will now form the linkage. So we have something like a CH2 here, right? Then you have this, you have this, you have this. Of course, you see that there's now a double bond here, because as this bond is packing up here, it forms a double bond here, right? So that double bond is what I have here. Then I have my arrow attached with this arrow. Are you getting it? Then this red arrow here is telling us that there will be a linkage between this and this. So that linkage, let me put it here. Now this one also is telling us that there will be a linkage. So that linkage, let me put it here, and then you have this closure here. And then finally, what are you going to have here? Arrow. So this is the product of this reaction, which I can decide to draw once as something like this. Just that CH2, I placed it there so that you know what we are doing. Okay. This is this. I decide to draw it like this, and I say arrow and what? Arrow. So you see that is, sorry about that. You see that is a very simple reaction. Now, how about if we turn the dienophile, because this dienophile can react in two ways. How about if we turn the dienophile to something like this? Let's say you have this is the diene, right? This CH2. Let's say you turn the dienophile. Instead of it to be facing, the arrow to be facing down up, let it face up. So you have, let's face down. So you have arrow and then double bond here like this. How would the reaction now look like? It's still very easy, right? This one will come here. As this one is coming here, this one passes up here. This one comes here. So the product will be something like this, which is almost the same thing. There will be a double bond here, and then there's a linkage here. Of course, you know there's arrow group here, and then you have this group close, and then the what? Arrow. So you can see that this one can be in two ways. So the product of this reaction can either be in the form of this double bond, arrow, arrow, or in the form of this double bond, arrow, arrow. Okay, now how about this? What would you say is the product of this reaction? Everything is still the same. This is diene, and diene rather, and then this is the what? Dienophile. What happened? This one comes here, this one packs up here, this one comes here. Okay, and then at the end of the day, what you are going to form is something like this. This is CH2, right? Of course, you know you have CH2 here. What are we going to have here? Double bond, because this double bond is packed here. Then this red arrow is telling us that there is a linkage. This one is also telling us that there is a linkage. They will now draw this group. This group will no longer be there because this double bond is what's actually attack here. So that's why most times we don't have double bond here anymore. And then we'll have COO, ME, and then COO, ME. Are you getting it? Which I can invariably write as, I can write this as something like this. We have this, and then you have this, and then you have COOMe, COOMe. So this is the product of this reaction. Now let's check another. How about if you are given something like this and you are asked to predict the product of this reaction? What do you think it will be? Now, what is reacting is the diene and the dienophile. So the question is, which of them is the diene? Of course, you know this is the diene. How do you know the diene is the one that has a double bond in such a way that there is only a single bond in between them? So this is the diene, and then this is the what? Dienophile. Now this can form various structure, right? Now what do? This dienophile attacks the diene, because since we say it's diene loving, it's the one that attacks. Are you getting it now? So the dienophile attacks here. As it's coming to attack here, what do you think will happen? This bond here will pack up here. As this bond is packing up here, what do you think will happen to this one? This one here will come and pack up here to form the linkage. So the product of this reaction will be something like this. Take note of what I'm trying to do here, or what I will do here. You have this, which is this link here. Then you have something like this. Okay. And then you have the oxygen in the middle, which is this oxygen. Note that the linkage is not between here and here. The linkage is between here and here. So if anything wants to be formed, it will form between here and here, here and here. Are you getting it now? So the oxygen will just be like in the middle. So you have something like this, and then you have, you have something like this, and then you have this linkage that links this, okay, to this carbon, and then you have this, okay, coming here, then oxygen, then you have the double bond oxygen, double bond oxygen. Now recall that this double bond passed up here, so we have a double bond here, and this will be the product of the reaction. It seems technical, right? Yeah, but we just have to memorize it or learn it. It's very easy. I said that the linkage, you see, the linkage is usually between here and here. So what we have, the linkage is supposed to be between here and here. So if you trace exactly what we have out, this structure, the way it is, if I want to draw it, I will draw it as something like this. Abina. That is exactly what we have here. Do you understand the concept now? But there will be no double bond here, because this double bond is what is coming to react here. Okay? So that is for the Diels-Alder reaction. Let's look at the last example. Okay, say stereochemical considerations. Now, another thing that you must also consider in the Diels-Alder reaction is the diene must be in the cis form. Okay? The diene must be in the cis form. This must be in the cis form. And the dienophile, any stereochemical position that this dienophile actually assume will also show in the product itself. Is that understood? So if we actually do this now, this one will come here. According to the reaction, this one comes here. Say it's a one-step mechanism. You see, everything we are doing is just one step. This one comes here, this one comes here, this one comes here. Okay? So the product of this reaction will be something like this. You are going to form, from what we have been doing since, I don't need to actually go much in details. Double bond will be here, and then what do we have here? CO2 Me, and then CO2 Me. Now if you look at this compound very well, you discover something, that all of them, they are in the cis form. So if I want to talk about the stereochemistry, I can decide to use this to illustrate. Now when you use something like this, it means that they are in one plane. Are you getting it? So all of them, they are in the cis form. However, if you look at this one, what happens here? This one attacks here, right? As this one is attacking here, this one comes here, and then this one comes up here, right? So we are going to form something like this too. Double bond. Now, but this one, things will change. This one can be in the normal cis form, CO2Me. But you can see that this dienophile is in the trans form. Why this dienophile is in the what? Cis form. Now, when it's in the cis form, you use this arrow to represent the two, that they are in the same plane. Now, in the trans form, you now use this half, what is it called? This broken arrow or broken wedge to indicate that this one is in the trans form. So when you see something like this is a trans, and this is what? Cis. So you must also take this into consideration. But in most cases, the diene must be in the cis form. You see that both diene are in the cis form. If the diene is in the trans form, the reaction will not occur. Are you getting it? If the diene is in the trans form, the reaction will not occur. But if it's in the cis form, then the reaction will occur. But the dienophile can either be in the cis or the trans. Okay, so that will be all for the cycloaddition reaction, the diader cycloaddition reaction. I believe we did justice to this. If you have any question on it, please try to message me, email me, DM me, or WhatsApp, or wherever, so that you get more clarification on it. Thank you very much for your time. God bless.